Scalar multiplication of a vector changes the magnitude and the direction of a vector. For instance, the multiplication of 3 with vector A increases the length of vector A by 3 times its original size, whereas the multiplication of -1 with vector A changes the direction of vector A, which is now on the opposite or negative direction to the original vector. And finally, the multiplication of vector A with half decreases its magnitude by half. Let's look at the product of scalar and vector valued function. F of t is x1 ti plus y1 tj plus z1 tk, then alpha, which is a scalar, multiplied by f of t, which is a vector valued function, is simply alpha x1 ti plus alpha y1 dj plus alpha z1 dk. If we have the vector valued function 5 sine ti plus 5 cos tj plus 18 dk, then to find negative f of t, we simply multiply -1 with our vector valued function 5 sine ti plus 5 cos tj plus 18 dk, and we would get -5 sine ti minus 5 cos tj minus 18 dk. Now, if we were to multiply 5e to the t with our vector valued function, 5e to the t is simply a scalar. We would be using the same method as previously discussed, multiplied with 5 sine ti plus 5 cos tj plus 18 dk. We would get the answer as 25e to the t sine ti plus 25e to the t cos tj plus 90 e to the t k. Now let's discuss how do we add two vectors. One way is by arranging the beginning of the second vector where the first vector ends without altering their direction. Now vector a plus b starts at the beginning of vector a and ends at the end of vector b. This is vector a plus b. The sum of vector valued functions is easy. We simply add up the components of the same group together. Well, if we have two vectors f of t and g of t here, we would be summing up the components of I together So we get x1t plus x2t I, and the components of j together, y1t plus y2t j, plus the last component z1t plus z2t k. Now what if you were asked to find f of t minus g of t? One way is to find negative g of t first, which is simply negative x2 ti minus y2 tj minus z2 tk, and then we would add up f of t with negative g of t. F of t is x1t minus x1t minus 2t I, because it's still a sum, yeah, so this is plus y1t minus y2t, y1t minus y2t j plus z1t minus z2t. Okay, as easy as that. To deepen our understanding, let's look at more examples. You are asked to find e to the t f of t plus 4 g of t. Since we are now experts, try to solve this at one go. So we would have e to the t, f of t is simply 3ti minus j plus 3 cos tk plus 4g of t, and g of t is minus ti plus 2tj minus to2k, right? And so we would get 3e to the t ti minus e to the tj plus 3e to the t cos tk minus 4ti plus 8tj minus 4 multiplied by t over 2 is simply 2t. Okay, and we would add the same components that belong to the same group together. So now we have 3e to the t minus 4t I plus negative e to the t plus 8t j plus 3e to the t cos t minus 2t. Okay, I think this is it. There's nowhere else to simplify unless you would like to factorize t here, but I'll just leave it as it is. Let's discuss the length or magnitude of the vector valued function. The magnitude is simply the square root of the sum of squares of its components. Now in this case, the magnitude of the vector f of t would be the square root of the sum of squares of the component x1 of t square plus y1 t square plus z1 t square. When you want to find the magnitude of a scalar multiplied with the vector valued function, we simply take the absolute value of the scalar multiplied with the magnitude of the vector valued function. Let's look at an example. So given vector b as minus 1, 6 and 4, find the magnitude of b. The magnitude of b is simply the square root of the sum of squares of its component. 6 square, 4 square, 136 and 16 square root of 53.